Hi grade 12s, let's do this question on analytical geometry. So the information says, the diagram below shows a circle with center P. So okay, P is our center, and then they give us the equation of the circle. The circle cuts the y-axis at point R, so that's the y-intercept of the circle, and RT is a tangent to the circle. And this tangent cuts the x-axis at T, so this is the x-intercept of the straight line. And an angle theta is indicated. Also, theta is up here. Let's go to the questions. Question 4.1 says, determine the coordinates of P as well as the radius of the circle. But you see, grade 12s, the equation of the circle is not in standard form. So we can't see the center. So let me write down what they gave me. Okay, so they gave me this, eh? So I am going to complete the square now to get this equation in standard form. So how do we do this? First thing, you get all the x's by itself, eh? So I'm going to get x squared minus 6x by itself. And this y squared and that y, I'm going to get by itself. So I'm going to put them together. So this one, and I must always make sure the constant is on the other side, okay? So now I'm going to add something here, and I'm going to add something here, okay? But what I add here, I must also add on the right-hand side. So I'm going to complete the square now, eh? So I'm going to say 6 divided by 2. So 6 over 2 is 3. And then I ask myself, but what is 3 squared? The answer is 9. So 9 will go there. And then I will look at this 4 over here, and I will do the same. 4 over 2 is 2. And 2 squared is 4. So that 4 will go over there. But now I must remember, grade 12s, whatever you add on the left, you must add on the right. So I'm going to add the 9, and I'm also going to add the 4 on the right-hand side. Eh? And now I'm going to factorize. So this is a trinomial, so it will go in a bracket like this. Then I'm going to ask myself, what's half of this? It's 3. And if there's a minus, I have a minus there. Plus. Just remember everything is squared, eh? Then plus, here I have a y, there's a minus, so I also have a minus. Then what's half of 4? It was 2, everything squared. And on the right hand side, you add all these numbers, and you should get 25. And now I can see the center. The center of the circle, or let's rather call it P. P is the center of the circle. It's the opposite sign. So if that is a negative 3, this is a positive 3. If this is a negative 2, this is a positive 2. That's the center. And this is r squared. So if r squared is 25, then the radius of the circle is the square root of 25, which is 5. And that's how you answer that question. Let's mark that. So for completing the square, this whole process over here, that's a mark. For changing the right-hand side, that's a mark. For your center and for your radius. That's how you will get your 4 marks, eh? Okay, our next question is 4.2, and it says, show that the coordinates of R is 0 and 6. So show that R is 0 and 6. So when we read our information over here, it says R is the y-intercept of the circle. So to get the y-intercept, we're going to make x 0. Eh? So I'm writing that equation down, and I'm going to let x be 0 because I'm looking for the y-intercept. Eh? So wherever there's an x, that will be 0, and that will be 0 now. So let's do that. Okay, I replaced every x with a 0. So this is y squared, 0, and this 0 will fall away. And I have minus 4y is equal to 12. So this is a trinomial, like that. And you can use the formula grade 12s, or you can factorize. Eh? I am going to factorize. So y and y, 6 times 2, a minus and a plus. So I get y to either be a positive 6, or y can also be a negative 2. And that makes sense, eh? Because there's 2 y-intercepts. This is the y-intercept of the circle, and this is the y-intercept. Because that is where the circle cuts the y-axis, eh? R will be a positive y, and S will be a negative y. So therefore R is the positive y. So therefore, R is 0 and 6. And there we proved it, eh? For 2 marks. 4.3 says, determine the equation of the tangent RT in the form y is equal to mx plus c. So determine the equation of the tangent. Very important question, eh? So let's write our steps down. To find the equation of the tangent, so we need the gradient of the radius of the circle, but this radius must go to the tangent, eh? So here from R to P, there you can draw in a little radius, eh? So make sure the radius hits the tangent. So the radius can't be over there because there's no tangent over there, okay? So I need to work out this gradient. Now remember we have P. We said the coordinates of P is 3 and 2. So let's put that in. P is 3 and 2. And then we also worked out R. R is 0 and 6. I'm going to work out the gradient of that line, eh? So this is 9.3. So the gradient of the radius is this y minus that y. So 2 minus 6 over this x over that x. That's 3 minus 0. And I get my answer to be negative 4 over 3. So now I can conclude what the gradient of the tangent is because these lines are perpendicular. So I'm going to write therefore the gradient of the tangent. If this is negative 4 over 3, the gradient of the tangent is a positive, so the sign changes, is a positive 3 over 4. Okay, so I did that. Now I'm going to substitute a point. So let's write the standard form down. Y is equal to mx plus c. Y is equal to 3 over 4x plus c. Because we worked out the gradient of the tangent. Now I'm going to substitute a point. But the point must be on the tangent. The point can't be just a random point. It can't just be a random point. Eh? So do you see here? 0 and 6. Let's sub in 0 and 6. So 6 is equal to 3 over 4. This is now 0 plus c. So I get this to be 0. Eh? So 6, 0 plus c. C is 6. So therefore the equation of the tangent is y is equal to the gradient x and then plus 6. And that's how you work out the equation of a tangent. Okay, our next question is 4.4 and it says, determine the size of theta. Correct to 1 decimal place, okay? Don't make a mistake there. So we have to determine the size of this angle over here. So we need a plan, eh? So when you look at this question, we don't always start with a question. Like the question is looking for theta. We might start somewhere else, eh? So the first thing I know is that I know that this angle is 90, there by the origin. Can't we work out this angle of inclination? This is an angle of inclination because it comes from the x-axis and it hits the line. I'm going to call this x. So my plan is to find this angle, then I can work out this angle, then these two are angles on a straight line. So that's my plan, eh? So x hits this line. So I need the gradient of this line. Now remember this line is the tangent, eh? So I'm going to write this down. This is 4.4. Okay, so we know the angle of inclination is tan theta, but in this case it's tan x, eh? Is equal to the gradient of the line that the angle hits. So the gradient of our tangent was 3 over 4. So to get x, I'm going to say on my calculator, shift, then tan, then 3 over 4. And then I'm going to press equal. The answer you must get there for x is 36,86. So this angle over here is 36,86. Okay, then I'm going to do interior angles of a triangle there and find this angle over here, this angle over here. So I'm going to call that angle, angle T. Then it hits R, then it comes to O. So that's what I'm going to call that angle, eh? So I'm going to write TRO plus 36,86 plus 90 must give me 180. Angles in a triangle. So angle TRO is 180 minus 90 minus 36,86. And then I get TRO to be 53, 14. So I know theta plus this angle is angles on a straight line. So I'm going to go theta plus 53, 14 is 180 because of angles on a straight line. Okay, so theta is 180 minus 53, 14. Theta is 126.9 if you round off to one decimal place. And that's how I would work that out. These other methods, shorter methods, but that one is the safest. Let's look at 4.5 of this question. So it says a vertical line is drawn as a tangent to the circle P. So this circle is called circle P. That's just the name of the circle. So now we are drawing two vertical lines. So do you agree the one line will go there and the other line will go there if it's tangents, And then they say the tangent is drawn at point Q. So there's a point and there's a point. And then they say this is Q or this can be Q. We don't know which one is Q. It's this Q or that Q. But the coordinates of Q is A and B, where A is a positive. A refers to the X coordinate. So this X coordinate is a positive. So do you agree that over here the X coordinate will be a negative? And over here, the X coordinate will be a positive. So they are actually referring to this point. They are referring to this point over here. So now they want to know what's the coordinates. So this is going to be inspection. From P to Q, you can draw in a horizontal line. So the coordinates of P was 3 and 2. So Q's Y value is definitely also going to be 2, because on a horizontal line, the Y values are always the same. So the Y values are always the same. So now we need to figure out what this A is. So because Q is on the circumference, I know this line from P to the circumference called a radius, and we know that the radius of the circle is 5 units. Let me write it here. Let's say you have P over here and Q over there. P is 3 and 2, and Q is something and 2. But now the distance from P to Q is 5 units. So to get to this value, I am going to say this 3 plus the 5 units will give me this 8 over there. So the coordinates of Q using inspection is 8 and 2. Our next question is 4.6. This looks like a trickier question. So let's see for 4 marks. For which values of K, so this is the K. K refers to the Y-intercept of this straight line. This is a straight line. So this K refers to the Y-intercept. Okay? So for which values of K will this line, for which values of K will that line be a secant to the circle? Okay? So a secant is a line that cuts the circle twice. So a secant will be like this. Do you see it touches twice there and there? But once it gets here, it cuts it once over there. That's a tangent. So this is now a tangent. So that's a tangent. And this is a tangent. So let's highlight the two tangents. So my plan is the following. I'm going to write the equation of this one down. The equation is y is equal to 3 over 4x plus 6. So the y-intercept, remember K refers to the y-intercept. The y-intercept is 6 there. So I'm now going to work out the equation of this tangent over here. So for the equation of a tangent, I am going to need a point of contact. I need this point. And I also need, so I need a point of contact and I need the gradient of the radius. Okay? So P is 3 and 2 and R is 0 and 6. But if I had to draw a line here, this is equal to that. So P is actually the midpoint. So I'm going to use the midpoint to calculate the coordinates of this point over there. this point of contact over there. So I'm going to say, to get from 0 to 3, I added 3. So to get from 3 to this point, I must add 3 again. So I get this to be 6. Then I'm going to do the same for the y's. So I'm going to say, from this y to that y, I minus 4. So from this y to that y, I'm going to minus 4. So 2 minus 4 is negative 2. So there's my point of contact. So I have a point of contact. So tick, I have the point of contact. Let's work out the gradient of the radius. So I'm going to say it's this y minus that y. So that y minus that y over this x minus that x. And I get the gradient of the radius to be negative 4 over 3. Okay. So that means, so therefore the gradient of the new tangent, so this tangent over here, that gradient is a positive 3 over 4. Okay, so because this is a negative, this one will be a positive. And because this is 4 over 3, this one will be 3 over 4. Why? Because the tangent is perpendicular to the radius. Okay, so far, for my new tangent, I have this. And I'm going to substitute a point. So the only point I have is this point of contact. That point is 6 and negative 2. So I'm going to sub that in. So I get this to be negative 2. 3 over 4x. The x becomes 6 plus c. And I get my c to be negative 13 over 2. So therefore, the equation of the other tangent is 3 over 4x minus 13 over 2. So let's put that in now. This equation is 3 over 4x minus 13 over 2. So they asked us this question, if you have a straight line like this, and you must have a y-intercept, what must the y-intercept be for this line to cut the circle twice? So remember, a secant is when a line cuts the circle twice. So K refers to the y-intercept. So do you agree, grade 12? This line must be here in the middle somewhere. And if that line is anywhere in the middle, yet can be any one of these lines, the value of the y-intercept must then be between this y-intercept, which is somewhere here at the bottom, and this y-intercept, which is there. So the answer is K must be between negative 13 over 2 and 6. If that is the y-intercept, if the y-intercept is between any of these numbers, then the line will cut the circle twice. And that's how you do that question. The last question, 4.7 says, another circle M with this equation is drawn. Okay, so we have this new circle. There's the equation of the new circle. Will circle M touch or cut circle P? Or will it neither touch nor cut the circle? So here's our options. They will either touch or they will cut, so they will intersect, or they will not touch and they will not intersect. So that's our three options, and we have to prove this. So here I have a summary that you can use to find out if circles touch or if they don't touch or if they intersect. The first thing I would do is I would work out r minus r and r plus r. So I'm going to write down r refers to the radius of the bigger circle. Okay. And then small r refers to the radius of the smaller circle. And then this d refers to the distance between the two centers. So the distance between the two centers. The one circle is x minus 3 squared plus x minus 2 squared is equal to 25. So that was the one that was given. The equation of the other circle is this. and y plus 2, but this is 36. Okay, so the bigger circle is this one. So we look at the bigger radius. Okay, so let's write down r is the radius of the big circle. So the square root of 36 is 6. Small r is the radius of the smaller circle. So that is the square root of 25, which is 5. So now I'm going to write, I'm first going to do this, then this. So I'm going to minus them. So 6 minus 5, so this is r minus r. 6 minus 5, the answer is 1. Then I'm going to do r plus r. So r plus r is then 6 plus 5, and the answer is 11. Okay, so I've worked that out. Now I'm going to work out the distance between the two centers. So the center for the first circle is 3. So this and this. So 3 and 2. And the distance and the center for the second circle is this and this, opposite signs. So this and this. And I'm going to use the distance formula. This is circle P, this is circle M. So MP is equal to distance formula, this x and that x. So we minus them. So this one minus that one. Everything squared. This y minus that y. So minus that squared, all in the calculator, and you should get 7, 1, 7,21 units. Okay. I'm going to write the distance down. The distance is 7,21. So can you see that this 7,21 is between these two numbers? So the distance is between r minus r, because this was 1. And it's between r plus r, this was 11. So let's go look. So that means the circles intersect at 2 points, eh? So therefore, I'm going to write there, therefore, the circles will cut twice. And that's your answer. And that's how you get 4 marks, eh? So if you want to rewrite, you can write 7,21 is between 1 and 11. And therefore, the circles will cut twice.